Hey, welcome to your Wednesday independent work. We're going to go through this Unit 2 review Desmos that me and Mr. Wong decided would be a good review activity for you to do, knowing that you have a test in your math class tomorrow or Friday, depending on what class period you're in. So this is sort of designed to just go back and look at some of the things we've learned throughout Unit 2 so you can be successful on your test. So let's look at it. I've already got the first screen open. It says, where should you decide to group this card, and what features of the table were important? So it's weird, kind of weirdly, because it's weirded kind of weirdly. It's worded kind of weirdly because it's asking you how did you decide where to group this card, and you haven't really done it yet. Just to clarify, a lot of these questions are taken from the very end of your classwork Desmos activities. So like this question is, it's like assuming you just did this if you were working on the activity that this question came from. So, all right, so let's take a look at this table. Is it proportional, yes or no? Well, to be proportional, you would need the ratios between the x and y value to be the same in every single row. Or in other words, you would need a constant of proportionality, some number that when you multiply it by the x value, you get the y value every time. Well, my favorite way of doing these to check these is I pretend that there's this third column on the end of the table, and I call it the y divided by x column. And then I do exactly that. I do the y value divided by the x value for every row. And if all those numbers come out the same, then that tells me that the ratio between x and y is the same in every row. And that number that I keep getting is the constant of proportionality. So it kind of like kills two birds with one stone for me. I'm checking for proportionality, and I'm getting the constant of proportionality in the same step. I'm going to skip this first row though, because you can't really do 0 divided by 0. If you try to divide by 0, that's what mathematicians call undefined. Undefined just means it doesn't really have an answer. So don't worry about the 0 and 0. We know 0 and 0 are good. We're supposed to have them if it's a proportional relationship. All right, so 4 divided by 2 is 2. 16 divided by 4 is 4. And 36 divided by 6 is 6. I'm getting different numbers here every time. In this row, the y value is twice as big as the x value. In this row, the y value is 4 times as big. And in this row, the y value is 6 times as big. So I would definitely group this with the not proportional group. I'm gonna draw a big ol' blue arrow to there. And then, to be perfectly honest, I don't really know what the question means when it says what features of this table were important. I would just answer this by describing how I decided. Well, so the first part of the question is how did you decide? So I divided the y value by the x value for every row. I got different quotients. Or when you divide numbers, the answer is called a quotient. I got different quotients in each row, so the ratios between x and y are different. Therefore, oh, my screen just got all weird. Give me a second. All right, therefore, this is not a proportional relationship. As far as what it means by what features of the table were important, I don't really know what it means by that. We just check the values. All right, so let's move on to the next one. All right, complete this table so that the relationship is proportional. So I always tell my students the very first thing you should do when you come across a table like this is find the constant of proportionality. Then you can use it to fill in your values. So the constant of proportionality is always a y value divided by an x value. This right here is the only row in which I have the y value and the x value, so it's kind of like I'm kind of forced to use these values. So this is 20 divided by 6. I could keep this as a fraction, simplify it. Let's see here. This is also equal to 10 over 3. I could divide this into a calculator, and if I put it into a calculator, I'm going to get this. I'm going to get 3.3333 going on forever for the rest of my life, right? I highly recommend you don't do that with Desmos, because as soon as you start having all these 0.33333 and you try to enter the answers you get from the boxes in that, like when we multiply this 3 right here times all these 3s, you're going to get 9.9999, and Desmos is not going to recognize that as the right answer, because it's only the correct answer if you are physically capable of typing an infinite number of 3s into the box. And if you are not capable of typing an infinite number of 3s into the box, then you can't put enough 3s in order to put the correct answer. So instead, we stick with fractions. This is one of the things that math teachers are always saying: fractions are superior to decimals in a lot of ways, and this is one of them. So we're going to use this 10 over 3 as our constant of proportionality. And so in order to fill in this box right here, I need to take the 3 from the x row, or x column, I mean, and multiply it by my constant of proportionality, which is 10 over 3. And now I'm going to think of this 3 as 3 over 1. And so I multiply and I get 30 over 3. But 30 divided by 3 is 10. So this is 10. And see, if we had tried to do 3 times 3.3333, we would have got 9.9999, and that wouldn't have been right. The answer is actually 10. And so there's some weird stuff happening there between decimals and fractions, and it's much better if you just stick with fractions if you're able to do that. All right, and so now to fill in this box over here, we need to do 200 divided by 10/3, because we're going back the other way from y to x. And so I'm going to use a strategy I love called keep, change, flip in order to do this division. So 200 over 1, I'm going to write it as a fraction, divided by 10/3. Well, if you keep, change, flip, keep, so I'm writing a K here, keep, change, flip. The way this works is you can do fraction division by keeping the first number exactly how it is. So 200 over 1 is just going to stay as 200 over 1. But then I'm going to change from division to multiplication. And then I'm going to flip 10/3 to 3 over 10. And now I can just multiply, and this is much easier. So 200 times 3 is 600. And 10 times 1 is 10. And so the answer is 600 over 10. If you divide that, that equals 60. And so the answer here is going to be 60. If you would try to divide by 3.333333 with a calculator, you probably would have got 60.111 or 60.33. I'm not exactly sure what the answer would have came out as, but it wouldn't come out as a perfect 60. And then Desmos would be marking you wrong, and you're like, well, I'm pretty sure this is right. I don't get it. So use fractions when you can, especially with Desmos. All right, let's move on to the next one. All right, so this one, we got to fill it in again. This time it's A and B instead of X and Y. We need to put the constant of proportionality in here. It's asking, what is the constant of proportionality? There are multiple ways to fill in this table. So the reason there's multiple ways to fill in this table is because there's no row that has an A and a B value. So there's nowhere for us to like do a division to decide what the constant of proportionality must be. So instead, we can make our own constant of proportionality. And I like to pick easy numbers personally. So I'm going to let my K be 2. So I'm going to go ahead and just put that in the box here too. I've decided that my constant of proportionality is 2. And so that means I have to do all of the A values times 2 to fill in the B value here. So I'm going to do 0 times 2. I'm going to do 1 times 2, 1/2 times 2, and 2 times 2. And those answers are pretty simple. This is going to be 0, 2, 1, and 4. You could have chosen a different k, and then you would get different numbers to put in these boxes. The last thing I need to do is divide 10 by 2 to get the a value here. So I'm working the other way. And so 10 divided by 2 is going to be 5. All right, the next one, let's see here, what do we got going on here? It says, examine the information about the 3 robot parts we worked on today. Okay, so this question got taken from the one where you had to build robots and put hats on them and that sort of stuff. It's okay, so I'm looking at the info given over here on the left side. I see a table, it says 3 and 6, 1 and 2. I see that it says the constant of proportionality is 2, and that the equation is h equals 2w. Okay, that's a lot of info. Now it says describe a strategy for writing an equation from a table of a proportional relationship. Okay, well, I know the very first step, but I always tell my students, the first step is find the constant of proportionality. You need that number for almost everything we're doing every time. Just get it off the bat. And look, and that's what they've essentially done here in the example, right? First thing they did was find that too. All right, and so now once you have the constant of proportionality, you just need 4 ingredients. You need the 2 letters that are in the relationship. In this case, it's H and W. And then you need the constant of proportionality, which in this case is 2, and then you need an equal sign. You only need those 4 ingredients. And you need to arrange them so that they say exactly what the relationship is doing. And so in this case, the relationship is if you take the width times 2, it equals the height. 3 times 2 equals 6. Again, here in the second row, if you take the width, multiply by 2, that equals the height. And so my strategy, I guess, would be arrange the variables and the constant of proportionality so that they describe what the relationship, or so I'm going to say that so that they describe the relationship. For example, in this relationship, the width times 2 equals the height, and that's 2 times the width equals h. I wrote it differently than they have it over here. They have it as h equals 2 times the width. I wrote it as 2 times the width equals the height. That doesn't matter if you like to flip it around. All right, next. Here is a table that represents a proportional relationship. Find the constant of proportionality and write an equation that represents the relationship. See, even in the instructions here, when the final thing you're supposed to do in this question is write an equation, and the first thing they want you to do is find the constant of proportionality. When you're taking that test tomorrow, please find that constant of proportionality first, and then that's the number that you need to throw in your equation. All right, so in order to find my constant of proportionality, I need to do a y value divided by an x value, right? K is always y divided by x. But this relationship doesn't have y's and x's, it has c's and d's, but that's okay. I know that y is usually the value over on this side, and x is usually the value on this side, so I'll just replace c where y is and d where x is. So this time it's actually going to be a c over d that I need to do. I'll pick this very first row just because the numbers are the smallest, it looks the easiest. So my constant of proportionality is going to be 6.28 divided by 2, and I'm pretty sure that's going to be 3.14. That's a familiar number. And so that's my constant, 3.14. And now, if you're stuck on writing the equations at this point, you should think about what that constant does for you, because what the constant does for you is exactly what the equation is trying to describe. The constant of proportionality is this number that allows you to go 2 times 3.14 equals 6.28. Or in other words, D times 3.14 equaled the C number, right? And in the next row, the D number times 3.14 equals the C number. When I say the D number, I'm talking about whatever number is in this first row. And when I say the C number, I'm talking about whatever number is in the second column. Sorry, I said row a moment ago. D number is in this column, C number is in this column. So again, if we go to the third row where there's a 5, if you do that 5 times 3.14, you get 15.7. It's not 15.7 exactly, it's like 15.72, but there's some like rounding going on here. So this relationship, essentially what's going on is if you take D, multiply it by 3.14, you get C. So let's write an equation that says that. Well, they already put part of it here for us. C equals 3.14 times D. Right, there's the equation we're looking for. You don't need any multiplication sign or parentheses or anything between 3.14 and D. When you put a number right next to a variable, as long as the number is first, then that means multiply the number times the variable. All right, it is snowing in Syracuse, New York. After 2 hours, 1 inch of snow has fallen. Okay, so 2 hours, 1 inch. Or, yeah, underline that. Yeah. All right, 2 hours. What the heck's going on here? Okay, so it says the snow falls at the same rate all the time. So it's not like coming down really hard for a little while and then like drizzling for a little while. It's like steady the whole time. That's what we need for proportional relationships. If it didn't do that, then we wouldn't really have a proportional thing going on. All right, so it wants us to complete the table. Well, I could find the constant of proportionality for this table. I think that's always the first thing you should do. This is also called a unit rate. These two things mean the same thing, K and the unit rate. In this question, I kind of like to think about it as a unit rate because it's like snow per hour, right? Like how much snow per hour is falling. And if you're in my class, you might remember that one day I said that if you just replace the word per with the words divided by, then you know exactly how to do the question, because in order to get our K, we need to do the snow divided by the hours. And so this one row here, I have an amount of snow and a time. It's going to be 1 divided by 2, which is just 1/2. So 1/2 of an inch of snow is falling every hour. So I'm going to do 1 times 1/2 equals 1/2 over here. And 7 times 1/2 equals 3.5 or 3.5 or 7/2, whatever way you like it. I'm sticking with fractions. So this is supposed to be a 7 over 2 here. And this one is a 1 over 2. All right, and so now we need to write this equation. So I just need an equation that says what's going on in the relationship here. The relationship is if I take any amount of time and I multiply it by that 1/2 of an inch per hour, then I get how much snow has fallen. So in other words, the snow equals 1/2. I'm going to write it as 0.5 this time though, because I know that when I try to put this 1/2 next to a variable, Desmos might act weird or something. You know what? I'm going to try it anyway. I'm going to go 1/2. Oh no, that works fine. It made it nice for me. Okay, so 1/2 times h, right? If you take any of the h values, multiply them by 1/2, you get the S value. And that's what this equation here says. Okay, plot the following points on the coordinate plane. Okay, 0, 10. That's 0 on the x-axis, 10 on the y. 1, 8. That's 1 on the x-axis, 8 on the y-axis. Okay, 2, 6. So that's 2 on the x-axis, 6 on the y-axis. So just remember always to go like left or right first. That's what the first number tells you, and then up or down on the second number. All right, so now I'm on 2. No, I already did 2, 6. So this is 3, 4. And then the last one is 4, 2. And now they want to know, is this a proportional relationship? I see one of the necessary characteristics of a proportional relationship in a graph. These points do appear to make a straight line. Geez, I was way off on trying to draw. I was trying to draw a straight line there. Hold on. I'm going to try again. Still terrible. All right, pretend that line is straight. So the dots are making a nice straight line, but there's this other rule about the graphs of proportional relationship. They have to contain this point right here. The line is supposed to touch this point that we call the origin, or 0, 0. If it doesn't touch that point, then it can't be proportional. It absolutely must. So both things have to be true. They have to make a straight line and touch that origin. And since it doesn't, then I know this is not proportional. The line does not contain. We like to, when we talk about lines on graphs touching specific points, we like to use the word contain the origin. Simple as that. That's all I need to see. That's enough evidence for me. All right, so make one graph that represents a proportional relationship and one other that does not. Okay, so let's see here. This one's going to be proportional, so I know it has to contain the origin, so I'll start my line right there. And then as long as the line is straight, it literally doesn't matter what I do from there. I could put it straight way over here. I could put it straight way over here. As long as it's straight, it's proportional. So I don't know, I'll go right there. All right, now this one, on the other hand, well, I know that if it doesn't touch the origin, it's not straight. So I could make a line that doesn't touch the origin, but we just saw that on the last question. What if I make this one touch the origin, but I make it not straight? I put a big old jagged corner in there. So now this one's not proportional, even though it does touch the origin. All right, so it says, then explain in words what makes a graph proportional or not, and why. The graph of a proportional relationship must be straight and through or contain whatever the origin. Those are the two characteristics. Straight line, contain the origin. And then it wants us to explain why, and also bonus for like why it's important for the origin to be on the graph. So I'll do both of those real quick. The straight line represents the equivalent ratios, in a proportional relationship. But if you think about, I'm going to move this line a little bit just to make the math easier to like explain. So with the proportional one, the line stays straight because both x and y are changing proportionally. Or in other words, the values are like going up at the same rate. So from this point right here, this looks like it's 2, 1 is this point right here. Well, if the graph goes over 2 more, then it has to go up 1, because that's sort of like the relationship that this is bound by, right? 2 of this, 1 of that. So even if you go over like 4 more on the graph, 1, 2, 3, 4, well, let's see here, 2 to 1, that's the same as 4 to 2. So if I went over 4, the graph must have gone up 2. Maybe I didn't really draw this that well. Maybe my line is off. 2 to 1. Why is that up 3 boxes? Now I feel like maybe something I said was wrong, or I'm looking at something wrong. Give me a second. 2 to 1. So this is 3, comma, oh, 1, 2 boxes, 1, 4 boxes, 3. Why? Is it just my drawing that's weird, or what? Or am I counting weird? Oh, no. I see what I did. All right. Geez, I really confused myself there for a second. I started at a weird spot. Let me change what I did. Eraser, please. Thank you. So I should have started from here when I was saying, okay, so if the graph goes over from 4, 1, 2, 3, 4, then it must go up 2, because that's an equivalent ratio to the 2 and 1 I did here. And then I could pick another value. I could say if it goes over 6, 3, 4, 5, 6, then I know it must have gone up 3, 1, 2, 3. Right? Both the horizontal movement and the vertical movement of the line are in equivalent ratios to each other, and that's why the line is sort of forced to stay straight. And then it says, explain why you have to have the origin on the graph. Well, let's see. The best way to explain it, in my opinion, is with a table, and then I'll write it. When you have values for a proportional relationship in a table like this, call this x, this is y, and maybe this is 2, and so, and maybe your k is 3, so x is 6 over, or y is 6 over here, and 2 times 3 equals 6, and so maybe you have a 4 over here, and so 4 times 3 equals 12. Maybe you have a 10 over here, so 10 times 3 equals 30. Well, what if you put 0 over here? You still have to do 0 times 3, and that's going to equal 0. And no matter what constant of proportionality I'd chosen, 3, 10, whatever, if I put a 0 in the x column, I multiply by that k, I'm going to get a 0 in the y column. And that's what that point 0, 0 represents. It represents 0 for x and 0 for y. So, so I'll type this for my answer. If the x value is 0, then no matter what k is, 0, I used to know how to make the dot for multiplication, but I don't. So I'm going to write 0 times k. That x right there is a multiplication x. I don't usually use those, but 0 times k equals 0, right? Which is represented by the point 0, 0, 0. All right, let's move on to the last one. What are 2 different ways you can find a constant of proportionality using a graph? Okay, so 1, take the y value from a point and divide by the x value. So in this case, it'd be that 12 divided by the 6, and the k is going to be 2. Second strategy, look for the 1, k point. the k is the y value. So what I mean by that is we know that k for this graph is that 12 divided by that 6, which equals 2. Well, what this 2 means is that you get 2y for every 1x, right? That's sort of like the rate of the ratio that's going on here. And so if we go to 1 on the x-axis right here, then you'll notice that the line crosses at 2, right? For 1x, we get 2y, or in other words, the point 1 comma 2. Well, this always works. You can always find the constant of proportionality if you know what the y value is, where x is 1. And so it's not always a perfect science because sometimes you can't tell exactly where the line is on the graph. But like just by looking at this graph before I did or drew anything, if you know that trick, you can just look at this graph and say, okay, here's 1. It looks like the line is at about 2, where x is at 1. So the k is probably either 2 or something really close to 2. And it turned out it was 2. All right, that's it. Good luck on your test tomorrow or Friday, whenever you take it. See you.